How does the space environment affect crystal growth? Imagine crystals forming in a place where gravity is almost non-existent. How do you think that changes the way crystals grow compared to on Earth? Well, it turns out the space environment has a big impact. When astronauts work on the International Space Station, they help scientists understand these differences firsthand. On Earth, gravity pulls fluids downward, causing currents called convection. These currents move heat and impurities around, which can interfere with how crystals develop. As a crystal grows, these movements can introduce tiny flaws or uneven structures, making the crystals smaller or less pure. That's why crystals grown on Earth often have imperfections. In space, the pull of gravity is so weak that convection currents are almost absent. Without these currents, the liquid around the crystal stays still, creating a calmer environment. This stability allows crystals to grow more slowly and evenly. The result is often larger, more uniform crystals with fewer defects. These higher quality crystals are especially useful in scientific research and medical studies. Astronauts play a key role in these experiments. They set up special equipment to grow crystals in microgravity. They carefully prepare samples, load them into devices, and sometimes make adjustments while observing the process. Their training helps them handle the equipment precisely, even in the weightless environment. This careful work ensures the crystals grow under optimal conditions. Growing crystals in space has many practical benefits. For example, protein crystals grown in microgravity are often clearer and more detailed than those grown on Earth. This helps scientists better understand the structure of proteins, which is important for developing new medicines. Space-grown crystals are also used to improve electronic materials and optical fibers, making technology better and more efficient. However, space is not perfectly quiet. Small vibrations from crew movements or equipment adjustments can cause tiny disturbances called G-jitter. These can affect crystal growth, so astronauts learn how to minimize movement and control these effects. This training is essential to get the best results from their experiments. Life aboard the International Space Station involves a lot of scientific work, including growing and analyzing crystals. Astronauts learn how to operate complex machines, troubleshoot issues, and work closely with scientists on the ground. The data they collect helps researchers make advances in medicine and technology. In the end, the space environment offers unique conditions that can improve crystal growth by reducing convection and sedimentation. Astronauts, careful training and daily activities are vital for maximizing these benefits. Their work in space helps scientists develop better medicines and materials, showing how human presence in space directly contributes to scientific progress.